Hello?
Hello.
All right, there you go. Yeah, you got to sing it. See, I heard someone there. All right, continuity. This is AP Calculus 1.3 continuity. Now, think about it. Basic term. What do you think continuity means? Continuous. Exactly. Continuity means continuous. It has to be continuous. Now, think about things that you want to be continuous. How about that roller coaster? Should that track be continuous? No? No? You don't want it to be continuous? So, would you mind having a hole in that track? A hole. So, a place in which that track is undefined. Would you want a hole in your roller coaster track? Oh, okay, so start to finish. Okay, start to finish. Okay, so there's an end somewhere, okay? So start to finish, not continuous, like you're not going to get on there and, after eternity's over, then you get off, right? Not that far, okay? But do you want the railroad, the track for that roller coaster to be continuous the whole time? Yes. Okay, you want it to be continuous, right? We want our functions to be continuous, right? Say yes. Yes, that's what we're talking about in continuity. If I say it is not continuous, that means that there's a hole somewhere in there. Okay, there's a hole somewhere in there. That means that I have a limit, I could have a limit in there that it would have a jump. What do you think a jump would be? Think of the roller coaster. Think about the roller coaster. Okay, but we're just talking about the track, though.
Like if it was higher and then just lower and then just.
Yep, there we go. That's a jump. So like higher to lower, right? So they're not. So the limit would not exist. They're both not going to the same point. That's what I'm talking about. That would be a jump right there. Okay. So a jump right there, or you're playing, I don't know, some game or something. I don't know. What's a game that you have to jump? I don't know.
Mario.
I know, Block Dude. Mario, there we go. All right. So, right there. So, if it's going the other way, you would have to jump to continue the track. There it is. Basic. Super basic. So, for it to be continuous, a couple things has to happen. So, on your guys' slide, yes, this is kind of small, but the main thing I want, it should be right there. Okay, these three things right here. I'll show you the examples that go along with it. F of C is defined. Okay, that has to happen. It has to be defined, right? So that C value cannot be undefined. Okay, very good. Okay, C is in the domain of F. Okay, so whatever your function is, sometimes you're going to have a restriction on your domain. You're going to say, all right, my function is only from here to here that I'm dealing with. That's important. Okay, is the C value in there to there? Yeah, that's important. Okay, if the limit exists. So now, hello, is it me you're looking for? I know. You know what? I'm trying to teach here, so chill. All right, I'm almost done. Okay? All right, so right here, so the limit has to exist. That means your left hand and right hand both go to the same number, right? Yes? Okay, good. Left and right hand both go to the same number. Now, this is the key piece right here. The limit of C is equal to F of C. That means the left hand, the right hand, both go to the same number, and F of C. So the function at that point also goes to the same number. So the limit left and right is both equal to the function at that point. So here is the example. This one's the example right here. So this is my left, this is my right, okay, and there's a solid dot right there. The left hand and right hand both go to the same number, and the function is equal to that same number, that's the limit. Here's an example of it not. The limit goes here, right? The limit goes here. but if you notice my function is down here. The f of c is down there. So this piece is not continuous. The limit is not equal to the function. That's what that means. Okay, so there's a hole in my roller coaster track here, right? I don't want to ride that one because that one's not continuous. Okay, same thing here, it's just not defined at all. Okay, so my c value is not defined at all. Here is one of my jumps. Okay, this is one jump here and here's another jump here. Okay, here's a jump where it is defined but at a different point down here. This is undefined at C, you know, both open dots on both top and bottom here. Okay? Okay, continuity at a number. Determine whether a function is continuous at a number. All right, first, okay, that guy that just walked in late, okay, what do I have to look at first when I do this?
Function?
Yeah, what do I look at?
Variable?
Yes?
If there's a hole?
If there's a hole, if there would be a hole, what would I have there? I'm looking at, before to figure out there's a hole, there's a,
Domain restriction?
excellent, that's why I called on you. Okay, domain restriction. There's a domain restriction. Look at this one right here. Is there any domain restrictions on this function? No. I'm not going to have any restrictions at all. So, if there's no restrictions at all, there's no place where it's going to be undefined, okay? There's no piecewise where I'd have a weird jump. This is going to be continuous at 1. Yes? Okay, that one's good. Now, the bottom. Determine if this one right here is continuous at 2. Again, what am I checking for? Domain restrictions. So the restriction on the domain is where? X equals 2. Can x equal 2? So I can say that x cannot equal 2. So, now, since I can already say that, it doesn't matter what the limit's going to be, right? It kind of does, but it's not going to be the same. Because I know that f of c is not going to be the limit as x approaches c of, no, that's not f, it's g. Dang it. I was all on a roll for that one too. G of x. I automatically know this is not going to work. I could actually factor this here. Okay, I could try to get this out to see if I can. It doesn't factor anyway, just so you know. Okay, it doesn't cancel. It does factor, but not cancel, because the top doesn't factor. The bottom does, but the top does not. So it's not going to cancel out anyway. So the g of c is not going to be equal to the limit at that. So automatically I know, because my domain restrictions, that this is not going to be continuous. This would not be a roller coaster I went to ride. All right. All right, let's see. Questions? No? All right, I'm going to leave you off right here.